Hi, today I'm going to do Khan Academy String Set 2 Problem 10. The problem tells us to design a URL shortener like bit.ly. So our requirements are to take in a long URL and return a shortened URL. Our second requirement is when accessing the short URL, redirect to the long URL. So to get started, we would think about this problem in terms of how many requests we'd be getting through our site, and that number can vary, but if we were to be taking in a lot of requests, like in the billions per month, we would want to design a system that could that wouldn't slow down. Part of this system would include caching, the 20% most, or 20% of our data that we're storing, because most likely the 20% of our data that we're storing is going to be some hot URLs that are going to be accessed quite frequently, perhaps maybe 20,000 requests for that particular link per second. So we would want to include some kind of caching system inside of this design. Before I get into that, let me just talk about sort of the bare bones essential thing that we need for this. We need to store essentially a hashed value for the long URL, which will be our shortened URL. It'll be a hashed version of the long URL. So we're going to have a schema that's going to store the hash, which will at most be, we put 16 characters here, but ideally we're only going to be using 6 characters of that, given that there's around like 68 billion different amalgamations you can do with just 6 characters of a SHA or an MD5 hashing function. So we are going to store our hash, and then we're going to store our original long URL. That's going to be the basic schema, and this could be done in a no SQL, since we're not going to really have any relationships for this design. In other more robust designs, we may consider having users, and with those users' IDs that could map to the given URLs that they create. But for our purposes, we're just going to have just a hash, and for the shortened and the original URL. So for our hashing function, we're going to use something like MD5, which will spit out 128 bits that will then encode with a base 64. And base 64 will give us upwards to about 21 alphanumeric characters, and we don't want all those characters because we're storing at most 16, but what we really want to be storing is 6. So we're going to just return the first 6 characters for that hash. And that was what we will map here, is the first 6 characters and then the original. So for URL shorteners, most of the time it's going to be, people are going to be doing lots of reads, because if it's like Rihanna retweeting a bit.ly link, you know, chances are she's going to have like hundreds of millions of people trying to access that link. You're not going to have hundreds of millions of people be making links or writing links. So that's why we would have a caching system for those hot links, like from Rihanna, for example. But let's go into the difference between write and read and how the sort of logic would work. So you're a client, you're Rihanna, and you go to you have like your new YouTube music video and you want to shorten that link. So you go to our site and you type in, you know, the link to your new music video. It's going to hit our server. We are going to hash that URL using this MD5 and then base 64 conversion. So we're going to do our hashing magic here. Then we're going to take that and store that hashed URL into our database with the original. And then we're going to send it back to the server, which should then return the shortened URL. However, if let's say you're one of Rihanna's followers and you just go to YouTube and you discover her video, not through her Bitly link, you're like, oh, I want to make a Bitly link. So then you take that same link that Rihanna made with Bitly, you go to Bitly, you type it in, the server tries to hash that URL and then store it, but then, oh, we see that there's a collision, meaning that hash already exists in our database. So it fails the collision, so it'll go back to our server, and our server will do some more magic by adding a suffix or an incrementing number to the end of the input URL. And it will do this until it reaches a sequence that hasn't been hashed before. And then it will hash that, that URL, store it in the database, and then return that shortened URL to the client. And now this Rihanna fan has their own unique Bitly link that they created that points to the same video. Okay, so that's with writing. Now if we were to read, which will be most of Rihanna's followers, what they're going to do is they're going to click on that Twitter link that she posted, and they're going to hit our server. And since there's going to be hundreds of millions of people accessing it, what we want to do is have a cache like Redis that will store that key value pair of the Bitly and the redirect. So it will search into the cache first to see if that has been visited before, because it's very expensive to go into the database if everyone is going into the database and trying to find that link. So we're going to try to hit your cache to see if it's been stored first. And if it has, then we're just going to, maybe it's your favorite video and you keep on going back to it, right? And you keep clicking on that link. So we're just going to hit your cache first, your in-memory, and then return what you've already seen instead of doing that expensive lookup. And then it will do a 302 redirect for you. However, if this is the first time you've accessed it and it doesn't find it, our server will try to find it in our database. And if it finds it, it'll come right back up to the server and do the 302 redirect to the original link, to the original URL. However, if it's not found, if it's not found, we would return back to the user. Let me put it in the same color. We'd return back to the user a 404 does not exist. So that way the user knows that, oh, this link doesn't exist. Maybe the person added an extra character onto the Bitly link when they were reposting it on Twitter, for example. Maybe someone copied Rihanna's link, put it on their post, and then accidentally added an extra character onto it. And then you clicked onto it, and then it went, tried to find it, not found, and then it took you to a 404 to Bitly, and it was like, I don't know where it is, not there. And yeah, so this is the basic flow of it. I know there's lots of other things to consider, but this is the underlying idea of how to design a Bitly URL shortener. Thank you.